Good afternoon, my dear students. So, my topic of today's presentation is resolution of forces. So, before going into details of resolution of a force, we will just revise the concept of resultant force. In last lecture, we have seen what is resultant force. Resultant of number of forces acting on a body is a single force which can produce the same effect as it is produced by number of forces acting together. Suppose we have forces of magnitude 10 Newton, 20 Newton, 30 Newton, 40 Newton, and these angles are given, say 30 degree, say 45 degree, 25 degree, 20 degree. So number of forces acting on a particle O are given. So this is a concurrent force system. And now we can combine all these forces 10, 20, 30, 40 Newton to give a single force. And that single force is called as a resultant force. It is denoted by this dotted line, say R. The angle made by resultant with horizontal will be say theta. So resultant of these four forces is will be a single force which when act with all these four forces produce the same effect as it is produced by the individual forces acting together. These individual forces 10, 20, 30, 40 Newton are called as component forces. 10, 20, 30 Newton, 40 Newton, etc. These individual forces are called as component forces, and R is the resultant of these component forces. Resultant force of these component forces. So resolution is just reverse procedure of finding out the resultant force. This, in another way, resultant R can be split up into four forces 10, 20, 30, 40 Newton. These individual forces are the component forces. So 10, 20, 30, 40 can be combined to get a single resultant, or vice versa. What is resolution? A single force R can be resolved into four forces 10, 20, 30, 40 Newton. Can be split up. A single force R can be split up, can be divided into four forces 10, 20, 30, 40 Newton, provided that the effect produced by this single force is equivalent to the effect produced by the individual forces, component forces. So this is resolution. So what is the definition of resolution? The way of representing a single force into component forces without changing the effect of that single force on the body. So resolution of force is just reverse process of finding out the resultant. Now, as you know, two forces in paragonal of forces, we have seen that two forces, say P and Q, acting at and away from the point, the forces are represented in magnitude and direction by the adjacent sides of the sphere. In case of parallelogram, The two forces are parallel. So here the forces are forming the sides of a sphere or a rectangle, and the diagonal of the square here represents the resultant of P and Q. P and Q are acting away from O. So what is direction of R? R is also acting away from O. We have seen the direction of resultant force. How to decide the direction? Forces are acting away from the point O. P and Q are acting away from O. So the direction of R should be away from O. In case of resolution, this is very important concept. What should be the direction of the components? Now P and Q, here P and Q are the components of R. Vice versa, P and Q can be combined to get a single resultant force R. So R is resultant of P and Q, whereas P and Q are the resolved parts. P and Q are the component forces. P and Q is the resolution of R. Got the concept of resolution of forces? Okay. So what should be the directions of P, Q and R? This plays a very important role in statics. Arrowheads play, statics is a game of arrowheads. Arrowheads play a very important role in statics. P and Q, P and Q. Now what is the direction of P? Away from O. What is the direction of Q? Away from O. So the direction of R is also shown here. Already the directions are shown. The direction of R is also away from O. If the force is pull, so this is a resultant force. If the force is pull, means away from O, the components must be away from O. This is simple logic behind it. If the force is pull, the components are pull. Force pull, components pull. Vice versa, if the force is push, components are also push. This is regarding the directions of components. When you resolve a force, you have to mark the directions of forces. Now see how to resolve a given force into two directions. Resolution of force is divided into two parts. Resolution into perpendicular components and resolution into non-perpendicular components. So let us see first part, resolution of force into perpendicular components. Into perpendicular components. Suppose this is positive x-axis, this is positive y-axis in two dimensions. Suppose this is the line of action of force F. Force F is acting at O. Length OA represents the magnitude of the force, and the arrowhead on OA gives the direction of force. So from point A on the line of action of force F, we draw a perpendicular on x-axis. We have to find out the components of F. We have to resolve F. What is our problem? To resolve F, to split up F into two components along x, along y-axis. So to resolve force F, to split up a force F into two directions x and y, we draw perpendicular from A on x-axis. Say B is the point where it is meeting at x-axis. So length OB is parallel to x-axis, or length OB represents x component and length AB represents y component of force. So how to calculate these values of Fx and Fy? Suppose the angle made by force F with positive x-axis is theta. What is theta? Angle made by F with x-axis. Always we take theta with x-axis, either with positive x-axis or with negative x-axis in respective coordinates. So theta is always with horizontal, theta h. So in this triangle, in triangle OBA, B is at right angle, so we take B at center. In triangle OBA, what is cos theta? Cos theta is AB upon, cos theta is adjacent side OB divided by hypotenuse. That is Fx divided by F. And what is sin theta here? Opposite side divided by hypotenuse, that is Fy upon F. So this gives very important equation. Fx is equal to F cos theta, Fy is equal to F sin theta. Theta is angle made by force with horizontal. Remember, when we use this formula, Fx equal to F cos theta and Fy is equal to F sin theta, theta is angle made by force with horizontal. So these Fx and Fy are called as components of force. Fx is x component of F and Fy is y component of F. If theta is with y axis, then Fx will be, if theta is with y axis, sometimes the angle is given with y axis. So what is the angle with x axis? 90 minus theta. So in this case, what is the value of Fx? F cos with F into cos of angle made by force with horizontal. F cos 90 minus theta, cos 90 minus theta is sin theta. So Fx is F sin theta. What is Fy here? F into sine of angle made by force with horizontal. F into sine. What is the angle with horizontal? 90 minus theta. So it is F into cos theta. Now the components are just reverse. Here it is cos theta in Fx. Here it is sin theta in Fx. Here it is sin theta in Fy. Here it is cos theta in Fy. So instead of remembering these two formulas separately, always if the angle is given with vertical, find out the angle made by force with horizontal and use this formula. Fx equal to F cos theta, Fy is equal to F sin theta, and remember theta is always the acute angle. Remember, acute angle less than 90 degree. Theta is acute angle made by force with horizontal. This is acute angle less than 90 degree in that respective quadrant, either with positive x-axis or with negative x-axis. Now for derivation purpose, we have shown this y component on the opposite side. Just for it, this is direction of x component, this is direction of y component. But force is acting at point O. So what is direction of Fx? Towards right. What is direction of Fy? Upwards. As I already mentioned, force pull, components pull. So here the force F is pull. The components Fx and Fy are also. So this figure is only for derivation purpose. This is Fy. So if we draw perpendicular on from this point, if we draw perpendicular on y-axis, if this is Fy, this length, say OD, is also y component. This is y component. This is x component. This is also x component. So this Fx and Fy form the sides of a rectangle. These are perpendicular components. So Fx and Fy are also called as orthogonal components, perpendicular components. So this is resolution of force into orthogonal or mutually perpendicular components or rectangular components. These are also Fx and Fy are also called as rectangular components of force because they form sides of a rectangle, maybe rectangle, maybe square, depending upon the magnitude of the forces. So this is regarding resolution of a force. So what is the difference between resolution and resultant? Resultant of number of forces, in this case, the number of forces are 2. The resultant of Fx and Fy, resultant of number of forces acting on a body is a single force which can produce the same effect as it is produced by the component forces Fx and Fy. Whatever effect is produced by Fx and Fy acting together on a body, the same effect will be produced by a single force F on the body. So Fx and Fy are components of F. We resolve F into two forces Fx and Fy. From this it is clear that minimum number of components of force are 2. Minimum number of components of force are 2. Very important MCQ question. Minimum number of components of a force are 2. Fx, Fy. So this is resolution into perpendicular components. Maximum number of components may be any. A force may have any number of components. But when we say minimum number of components of force are 2. Why a force may have any number of components? Because any number of forces can be combined into a single force, that is resultant. So resultant force, a single force, may have any number of infinite number of components, but the minimum number of components of force are 2. Remember this. Thank you.